Welcome back. Today I want to do a few more examples of compositions of trig inverse questions, kind of like what you might see on an assignment or a test. But we need to talk about it in two parts. So I'm going to do a couple of them specifically using unit circle values, and then we're going to talk about some kind of random values because it can really be anything at all. And in that case, we'll have to use some triangles and sketch some triangles in the right quadrants. Before I get into that, though, I do want to review one more time the domain and range of the arc trig functions, the arcsine, arccosine, and the arctangent. And I got those on the screen. If you still need to write those down for your notes or for future reference, you can pause the video and do that. But these things are really important, especially the range. We're not going to try to trick you too often with kind of weird domain values. But the range is especially important. So notice arcsine and arctangent have the exact same range from negative pi over 2 to pi over 2. What does that mean? That means if we're starting down here at negative pi over 2, we're going from here to 0 all the way up here to positive pi over 2. Okay? So, and that's going to be the case. So in other words, we're in quadrant 1 and 4 for arcsine and arctangent. For arccosine, notice it goes from 0 to pi. So that makes a little bit more sense. It's always these positive values. So for arccosine, it's going from 0 to pi. Okay, quadrants 1 and 2. So we got to keep that in mind moving forward. And I do talk about that a little bit more in a couple other videos I did earlier, which I'll link to at the end of this one. So let's move on here to our unit circle values. So know your unit circle before you do these, and you really work on your way inside out. So on this first question here, we're going to talk about first, what is the cos inverse of 1/2? What is that asking? It's saying that what angle does the cosine equal positive 1/2? We know the range is either quadrant 1 or 2. Since it's positive, that means we have to be in quadrant 1. So this guy right here is just equal to pi over 3. So the question boils down to, what's the sine of pi over 3? And we should know that that's root 3 over 2. Okay, and that's how all of these things work. So I'm going to zip through these pretty quickly, but if you want to pause the video for just a minute and see if you can do the rest of these, that would be a good thing, and then we'll pick it up from there. So I'm going to do this one next, so I'll call that number 2. And again, cosine of 3 pi over 4. All right, so we know the cosine of 3 pi over 4 is negative root 2 over 2. So the question now is, what's the sine inverse of negative root 2 over 2? Well, we know the sine inverse is in quadrant 1 or 4. It has to be in quadrant 4 since my sign is negative. And so that means we're in the 4th quadrant, and again, measuring those angles in a negative direction, so your answer here is negative pi over 4. The next one here, let's see, the arcsine of the cosine 5 pi over 3. Cosine 5 pi over 3, unit circle, you should know that as positive 1/2. So the arcsine of 1/2, same thing as saying inverse sine, of course. Arcsine of 1/2, quadrant 1, pi over 6. And the last one, arctangent is a bit trickier if you're not super familiar with your arctangent values, but arctangent is negative root 3, and again, we know this in quadrant 4, so that's going to be when sine is root 3 over 2 and cosine is 1/2. So that happens at negative pi over 3. And so it's asking, what is the cosine of negative pi over 3? And we know that's equal to positive 1/2. Okay, so again, tangents can be a little bit trickier, but you should be familiar with, even if you don't have them memorized, at least kind of where those values come from. And I wanted to put one more of these things. This is kind of a triple linker, but you do it the exact same way. And so we're still going to start on the inside, sine inverse of root 3 over 2, first quadrant. And I'll give you a second to do that one, see if you can work that out real quick. So the sine inverse of root 3 over 2 is pi over 3. So then we do the cosine of pi over 3, and we know the cosine of pi over 3 is 1/2, and now we come out to the grand finale, the inverse sine of 1/2 is pi over 6. So your final answer to that question would be pi over 6. Okay, so know your unit circle. It really helps if you have a good understanding and a good memory of the unit circle to do these things. But you just work on your inside out, remembering your quadrants. Okay, always remembering what the range of each of your arcsine, arccosine, arctan functions are. Let's go on to the second part of this. When you have to use a triangle. So now we have questions like this. And remember, what does it specifically? What does the arcsine, arccosine, arctangent return to you? It always returns an angle measurement. We generally use radians. We can use degrees in some application problems, but it's always going to return an angle. So take a look at this question. We have the tangent of the arccosine of 2/3. Well, that's not on a unit circle, so I don't know what that is off the top of my head, but we can still figure out the exact value of the tangent and be able to move forward from there. So this is how we do that. We still look at this and we still keep our range in mind. So I know this is going to end up being a positive value, so that means I'm in quadrant 1. So I can come over here to my XY axis, draw a triangle, doesn't matter how it looks, in quadrant 1, and I can label my sides, because if I let this be my angle theta, then that means the adjacent side must be 2 and the hypotenuse must be 3 because of SOHCAHTOA, and we know that just from way back when, right? So even though we don't know the exact value of that angle, I know that my triangle has to look like that because the cosine of theta has to be 2/3. So from here, now I can do the Pythagorean theorem. So I'm going to call this A, for lack of a better term. So I can set up my Pythagorean theorem, 2 squared plus A squared equals 3 squared. Subtract 4 from both sides. So A is equal to √5. And now it's a matter of finding the tangent. So the tangent, the actual final answer for this thing, the tangent we know is opposite over adjacent. So opposite over adjacent. So my final answer here is going to end up being √5 over 2. Okay? So that is how all of these things work out. You just have to keep in mind what quadrant you're drawing your triangle in and watch your positive and negative signs. Remember, you can only be in either quadrant 1 if everything is positive, and quadrant 2 or quadrant 4. You will not have a triangle in these kind of problems in quadrant 3. Okay, so I'm going to scroll down just a little bit and I'm going to show you 2 more of these. Go ahead and pause the video for just 1 minute and see if you can do those on your own. And then I'm going to keep on going and work them out with you. Okay, so hopefully you've got those 2 guys done. If you haven't, again, pause the video, please, and try to see if you can at least get the triangle sketched. For this guy here, we know that since the inverse sine of -3/5, that tells us we're in quadrant 4, since the sine is negative. So I'm going to draw my triangle down here in quadrant 4. And again, this is my angle theta that I'm talking about. The reference angle is always to the x-axis. So that tells me that the opposite side, -3, and the hypotenuse is 5. Remember, your hypotenuse is always going to be positive. We can do the Pythagorean theorem here. I can tell you just right off the top, I recognize this is a 3, 4, 5 triangle. So my adjacent side here would be +4. If you need to do the Pythagorean theorem there, by all means you can. And then the cosine of that angle adjacent over hypotenuse will be +4/5. Same deal on the last one here. The inverse cosine of -6/11. So this tells me here I have to be in quadrant 2. since my cosine is negative. So I'm going to draw a triangle here in quadrant 2. There's my theta. Adjacent over hypotenuse. So adjacent, that'd be -6 here. And the hypotenuse is 11. Pythagorean theorem again. So this would be 121 minus 36, which I believe is root 85. You can double check my math there, but that seems right. And so the sine of that angle, and notice that is positive, so in quadrant 2, the sine opposite over hypotenuse would be root 85 over 11. Okay, so it's just a matter of remembering your SOHCAHTOA, drawing the triangle in the correct quadrant, and then just going from there. I've got one more that I want to show you before I finish this up. This is kind of a calculus type of application. Take a look at that question real quick. So we have the tangent of the arcsine of 5x. You're like, well, wait a minute here. How can we work that out? Well, we do know, first of all, we know that x has to be less than or equal to 1/5 or greater than or equal to -1/5, just because of the domain issue. But knowing that, we do know we can go ahead and draw this thing in the first quadrant, and it's going to be okay. And again, I'm going to call that theta. And if I just call this 5x over 1, then I can call my opposite side 5x, my hypotenuse 1, and I can still do the Pythagorean theorem to find my adjacent side. So this would be 5x squared plus, I'll call this a again, a squared equals 1 squared. 25x squared plus a squared equals 1 squared, which is just 1. Oops. And subtracting all of that, so we got a squared equals 1 minus 25x squared. So a is equal to the square root of 1 minus 25x squared. And so the tangent of that angle, notice this is a 1 minus 25x squared. So the tangent of that angle is going to be 1, I apologize, it should be opposite over adjacent, it would be 5x over 1 minus 25x squared. So you will see something very similar to that next year if you go on to AP Calculus or Calculus in college, either way. But I do hope that gives you a short little overview of how to handle composition problems from using your inverse trig functions. I hope you got something out of this. Hope you have a little better understanding of how to solve problems like this. There should be some videos on the screen right now showing you where the domain and range of the inverse trig values come from, and also how to solve kind of more simple type of questions. Thank you again for watching, and we will see you next time.